Correlation versus causation. So in general, causation refers to the causal mechanisms that one variable, the explanatory variable or predictor variable or independent variable, has on another variable, the outcome variable, also called the response variable or dependent variable. And this can be partially observed as a correlation between two variables over multiple instances. It's just the correlation as we've been talking about. So for example, smoking, the independent variable, is correlated with cancer risk. And we can see that in the graphs. If you model years of smoking and then the relative risk of developing cancer, you can see there's a linear trend upwards. So there's a correlation between how much you smoke and your risk for getting cancer. Now, just the correlation itself is not the causation. The causation requires the further investigation of the causal mechanisms. The causal mechanisms, and essentially the answer of why are these two correlated. So you have to have a sufficient, convincing answer to establish the causal relationship. So correlation is not necessarily causation. Causation will usually involve correlation. So causation will have correlation, especially if you have a large N and you have an experimental design. However, to understand causation, one needs to understand the causal mechanisms and carefully study those processes and correlations of those mechanisms and then domain of interest. So when we see a person smoking and they don't just smoke and get cancer magically, there is deterioration of the lungs. There's other biological phenomena that are happening that are leading to the cancer. So it's not just the smoking itself. For example, it's not just that you're putting the cigarette on your lips. It's something deeper that is leading to the cancer that needs to be investigated. Also, there's an issue of causal direction that I just wanted to bring up here. It's kind of interesting to think about. So even with closely paired data, so if you're assessing two attributes of the same individual, it's difficult to determine causation without experimental evidence. So, and also, for example, causal direction is ambiguous. So there's a graph here, and there's also a conversation about this relating to schooling and higher earning. It's often assumed that the more schooling you have, the higher earning you make. However, it could also be that the higher earning potential leads to more schooling. So for example, people that are interested in earning more, or they have the capacity and the impetus to learn, to earn more, then go on to get more schooling. In the sense, the causal direction is inverted. So in a lot of cases, it gets pretty complicated to actually determine causation. But I just wanted to point out here that just mere correlation is not necessarily causation. I'll leave you with that, and I'll see you next time.